नमस्कार दोस्तों, कैसे हैं आप लोग। मैंने आपको ये दो क्वेश्चंस करा दिए थे। अब हम दूसरा क्वेश्चन कराने जा रहे हैं। क्वेश्चन है, फॉर अ फॉस्फोरस डूप्ड सिलिकॉन द मोबिलिटी ऑफ इलेक्ट्रॉन्स at T equal to 300 Kelvin is this much. Okay, the ratio of resistivity of the sample at T is equal to 500 degree Kelvin to T is equal to 300 Kelvin S. Now you must be knowing that mobility varies with temperature as follows: mu proportional to T to the power minus 3 by 2. Now conductivity of a semiconductor is, this is equal to Q n mu n plus Q p mu p. This is second equation, right? Now using relation in one, we have what? Mu n1, okay, by mu n2. So mu n1 is what? It is at actually 500 degree Kelvin, and mu n2 is what? It is at 300 degree Kelvin. And this is equal to what? That this will be 500 by 300 to the power minus 3 by 2. Now ignoring the whole component in equation 2. Ignoring whole component in equation 2, we have sigma, this conductivity is equal to Q n mu n, right? Because we have a pentavalent impurity phosphorus, and it is generally doped in N-type semiconductor crystal. You know what it is asking for? Resistivity. Resistivity is what? It is the reciprocal of the conductivity. Okay, so that means, okay, now this is ignoring the whole component. That means what you can do here, it is going to be 300 by 500 to the power, uh, 1 minute. Actually this is what, this mobility is directly proportional to the conductivity. This mobility is directly proportional to conductivity, right? So what you can here write it as 1 by mu n1 by mu n2, okay, and this is what, this is equal to 1 upon t1 by t2, okay, t1 by t2 to the power minus 3 by 2. So afterwards, what you can do here, you can do here as rho 1 by rho 2 is equal to t2 by t1, okay, as this is what, this is actually t1 to the power minus 3 by 2 and t2 to the power 3 by 2. So you can write it as t2 by t1 to the power 3 by 2. Okay, so this is what, this is actually 3 by 5 to the power 3 by 2. I think it must be like this way, na? Okay, so just you calculate it and you tell me the answer, what will be the answer here. Okay, simple is, the resistivity is the reciprocal of the conductivity. This is your conductivity and this is your resistivity, okay, and when 1 upon sigma, it is q and mu n. So that means that this resistivity is inversely proportional to the conductivity, which means that the conductivity is directly proportional to the mobility. Okay, this conductivity is directly proportional to the mobility, and this you know that mu is directly proportional to the power minus 3 by 2. So this resistivity is inversely proportional to the conductivity, which means this will be equal to mobility, and this mobility is proportional to the temperature T to the power minus 3 by 2. So if I take it as to be as rho 1 by rho 2, and this is, I can take it as T1 by T2. So this is will be equal to minus 3 by 2, na? 1 minute, okay. So this is actually 3 by 5 to the power minus 3 by 2, or 5 by 3 to the power 3 by 2, right? So it will come out to be as 5 by 3 to the power 3 by 2. So when you are going to solve it, it is like 125 by 81, and this is अंडर रूट अगर हम करेंगे, so what you will get it as, your answer will be 2.15. It will be 2.15, right? Next question is, a p-type silicon can be doped in the range from this to this. Okay, if the device area is this much and the thickness of the p-type region is limited to this much, the minimum possible number of minority electrons in neutral p-type region is, see the concentration of minority carriers, concentration of minority carriers, okay, in an extrinsic semiconductor is given by the law of mass action. That means n dot ni square. N is the concentration of electrons in the conduction band, and T is the concentration of holes in the valence band, and Ni is the intrinsic carrier concentration. So the minimum concentration of minority carriers, okay, minimum concentration of minority carriers is obtained from maximum doping level, is obtained from maximum doping level. So you know that uh, here n dot na is equal to ni, which implies this is equal to ni square n, okay, because what you have given the name. Okay, now you know that ni is given as 1.5, this 1.5 into 10 to the power 10 इसका whole square and divided by Na is equal to how much? It is 10 to the power 17, okay, per centimeter. Now when you are going to solve it, you are going to have 2250 centimeter per centimeter cube. So you can write it as 2.5 into 10 to the power 9 per meter cube. Now the maximum volume is what it is asking, the minimum possible number of minority carriers. Okay, now maximum volume is what? Maximum volume is equal to area times of P, thickness. So area is how much? This area is actually 1 centimeter into 1 centimeter, right? So it is 1 centimeter square into TP is how much? 200 micrometer, right? So this is 200 into 10 की power minus 6. This is 1 centimeter square. So this is 10 to the power minus 4 into 2 10 to the power minus 2 into power minus 8 per meter cube. Now, the minimum number of minimum number of minority electrons in this volume is capital N is equal to N into volume, right? How much? You have already calculated it as 2.25 into the power 9, and volume is how much? It is 2 into 10 to the power minus 8. So how much it is? 54 into 10 की power 1. So that means it is 45. Okay. So that means if you are going to solve it, you are going to have 2.25 into 10 to the power 20. Okay. If I am going to revise it, and this is 10 to the power 20, this will be 10 cube, this will be 2250 cent per centimeter cube. You have to calculate it in meter cube. Okay. As soon as you want to calculate it. Okay. So I have solved two questions. I hope that you have understood it well. Take out your copies and do it very well and practice it. Please like, share and subscribe. Thank you.